So for our lesson today, we're going to work on classifying triangles. So first thing we're going to review is a triangle is a figure formed by three line segments joining three non-collinear points. It just means that all 3 points can't be on the same line. If they were, it would not form a triangle. So here's 4 examples of different triangles. And today we're going to work on classifying them by both their angles and their sides. So when we classify angles by their sides, we have 3 options. If we have 3 congruent sides, like we do here on the left, remember that these little hash marks right here mean that those 3 sides are congruent. That is called an equilateral triangle. So equilateral means all 3 sides of your triangle are equal. If you only have 2 of these little markings, so you only have 2 sides that are congruent, that is called an isosceles triangle. So 2 congruent sides means you have an isosceles triangle. If you have a triangle that has no congruent sides, so none of the sides are the same length, that's called a scalene triangle. On the next slide, we're being asked to classify each triangle by its sides. So when we classify based on sides, in this case, we're going to look at all of the side lengths and determine how many sides are congruent. So looking at this triangle here, we have 2 sides that are both a length of 5. The one at the top is not. So we have 2 congruent sides, so this is isosceles. When I look at the triangle at the top right, all 3 sides have side lengths of 19, so this is an equilateral. So an equilateral because all 3 sides are the same. For the bottom left, we have a triangle with side lengths 6, 8, and 10. None of those sides are the same length, so this is scalene. And then last example in the bottom left, side lengths 5, 10, and 12 is another scalene. On the next slide, we're going to learn how to classify a triangle by its angles. If you have 3 acute angles, that means all 3 angles are less than 90 degrees. So remember, an acute angle is less than 90. So if I have 3 angles that are less than 90, that means it's an acute triangle. If I have 1 obtuse angle, that just means I have 1 angle that's greater than 90 degrees. So in this case, this angle down here is obtuse. So this is an obtuse triangle. For the third one, if we have 1 right angle, down here's the marking or the symbol telling me that this is a 90-degree angle, that means this is a right triangle. And then last, we have 3 congruent angles. That just means all of the angles are 60 degrees. So if all 3 angles of your triangle are 60 degrees, that triangle is called equiangular. So equiangular. On this next slide here, we're going to classify the triangles that were given by their angles. So if I look at the one over on the left side, that is green. I have markings telling me that all 3 angles in this triangle are congruent. Since all 3 of them are congruent, that is equiangular. If I move to the triangle on the top right, I have 2 acute angles and 1 obtuse angle. Since I have 1 obtuse, that makes this obtuse. And then the one on the bottom right-hand side, we have an angle measures 78, 22, and 80. All of them are acute angles, so this is acute. So moving on, we're going to classify each triangle by its angles and its sides. So when we look at these, we're going to talk about the angles and we're going to talk about the sides. So looking at question number 9, the first thing I notice right off the bat is I have this right angle here. Anytime there's a right angle, it's got to be a right triangle. When I look at the sides, I have 2 sides on this triangle marked congruent. When I have 2 sides congruent, that is isosceles. So this triangle is both a right triangle and an isosceles triangle. For question 10, the first thing I noticed, I was given an angle measure of 117 degrees. 117 degrees is obtuse. And it only takes 1 obtuse angle to classify the triangle as obtuse, so this one's definitely obtuse. We were not given anything about the lengths of any of these sides, so we're just going to assume that since none of them are marked, then none of them are congruent, so it would be scaling. Looking at question 11, we have angles that are all 60 degrees. So that means it's equiangular. And in this case, we don't have sides marked congruent, but we were given that each of the sides on this triangle are 7 centimeters. So that makes it an equilateral. Looking at question 12, I notice we don't have any information about any of the angles, but if we just look at them, there is not a right angle, and none of the angles look to be greater than 90 degrees, so we're going to call this an acute triangle. Again, it's acute because all 3 angles are less than 90 degrees. And then looking at my side lengths, I have side lengths of 15, 18, and 20. None of them are congruent to each other, so this is scaling. Question 13, first thing that stands out to me is this right angle, which makes it a right triangle. We have no information about the side lengths of this triangle, so it's got to be scaling. Question 14, we were only given 1 angle. This angle right here is 97 degrees. It is greater than 90, so this is obtuse. And then when I look at my sides, I was given that this side here is 5 feet, this side here is 5 feet. Since they're both 5 feet, these 2 sides have to be congruent. Since we have 2 sides congruent, that means I can classify my triangle as isosceles. So there's the classification of triangles by angles and sides. You will be asked to do this on your homework today. The next thing we're going to look at is the triangle sum theorem. So what you need to know about this is that the sum of the measures of the angles of a triangle is 180 degrees. So if I take and I add all 3 angles together, inside my triangle, they will add together to give me 180 degrees. So in this triangle that's pictured, so triangle ABC, if I add the measure of angle A to the measure of angle B to the measure of angle C, it will equal 180 degrees. On this slide, we're being asked to find the measure of the missing angle. So I'm going to start on the question on the top left. Top left, we were given that angle B is 15, angle C is 25, and we know that angle A plus angle B plus angle C has to equal 180. So then I'm going to go back through. I don't know angle A, but I do know that angle B is 15, and I also know that angle C is 25. And when I plug those two in, I can go ahead and simplify. So angle A plus 40 equals 180. I'm going to subtract 40 from both sides to know that angle A must be 40 degrees. Same thing's true for the triangle at the bottom. So the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 degrees. Does not matter what the triangle looks like. All three angles, when added up, have to equal 180 degrees. So angle A plus angle B is 61 plus angle C, which is 59, is going to equal 180. So 61 plus 59 gives me 120. I'm going to then subtract 120 from both sides to figure out that angle A has to be 60 degrees. And then the last one over here to the right, this time, again, angle A plus angle B plus angle C has to equal 180 degrees. But this time I'm missing angle B. So here I can plug in 56 for angle A. Angle B is going to stay angle B because that's what we need to figure out. Angle C is 34, and it's got to equal 180. When I combine 56 and 34, 56 plus 34 combine to give me 90. So angle B plus 90 equals 180. When I subtract 90 from both sides, I learn that angle B equals 90 degrees. For this one, we're going to add some algebra back into these problems. So here we were given information about angle E, D, and F, but we're being asked to find all those angle measures and find X. So we know if we take all three angles and we add them together, they're going to equal 180. So if we take angle D plus angle E plus angle F, they've got to combine to give me 180. Well, now we're just going to go back and we're going to substitute in the information we know. So we know that angle D is equal to 5x minus 2 plus angle E is equal to 9x plus 3, and angle F is equal to 11x minus 21. And when I add those together, they're still going to equal 180. So here we're going to go through and we're going to combine like terms. So here are my three like terms I'm going to combine. So 5x plus 9x plus 11x gives me 25x. Then I'm going to go through and combine these three terms. So negative 2, positive 3, pardon me, and 21. So those combine to give me negative 20, still equal to 180. At this point, I'm going to add 20 to both sides to get 25x equals 200. We always use this saying, beside it, divide it. We're trying to get rid of that 25 that's sitting beside the x. So we're going to divide both sides by 25 to get an x value of 8. So it filled out one of the 4 sets of information that we need to know. Then we're being asked to go back and find the measure of angle D. So to find the measure of angle D is equal to 5x minus 2. So I'm going to take 5 times 8 minus 2. Well, 5 times 8 is 40. 40 minus 2 is 38. So the measure of angle D must be 38 degrees. I'm going to repeat this process with angle E. So angle E equals 9x plus 3. I'm going to substitute x in. So 8 times 9 is 72, plus 3 is 75. So angle E must equal 75 degrees. And then the last one, angle F, 11x minus 21. So I'm going to take 11 times 8 minus 21. Should get a value of 67. So angle F equals 67 degrees. And if I'm going too fast, feel free to pause the video until you get caught up. Next question is very similar to the one we just did previously. So we're going to take angle P, Q, and R. We're going to add those 3 angles together, and they've got to combine to give me 180 degrees. So I've started with angle Q. Angle Q is 4x minus 22. And then I'm going to add angle P to that, 10x minus 4. And add angle R, x plus 11. And that's going to equal 180 degrees. Again, I'm going to make my life easier. Just go through and combine like terms. 4x plus 10x plus x is 15x. Negative 22 minus 4 plus 11 equals negative 15. Still equals 180. At this point, I'm going to add 15 to both sides. So 15x equals 195. Beside it, divide both sides by 15 to get x equals 13. And then to figure out our remaining values for P, Q, and R, we're going to take that x value and plug it back in. So for angle P, we're going to take 10 times 13, which is 130, minus 4 to get 126 degrees. For angle Q, we're going to take 4 times 13, which is 52. And then we're going to subtract 22 to get a value of 30 degrees. And then last one, angle R, we're going to take x plus 11. So 13 plus 11 is 24 degrees. And there's a quick way you can check yourselves. If you add all 3 of these values together, they should add up to be 180 degrees. In this case, they do, so we know we've done everything correctly. The next theorem we're looking at is the exterior angles theorem. So the exterior angles theorem tells us that the measure of an exterior angle of a triangle is equal to the sum of the 2 remote interior angles. So in this diagram, angle 1 is our exterior angle. I know that angle 1 is equal to the measure of angle A, whatever this angle is in here, plus whatever this angle is up here. So notice angle A and angle B are not touching the angle that the exterior is associated with. So angle 1 is associated with angle C, so we can't add angle C in there. So let's practice some of these. So find the measure of angle 1. The first one we're looking at is the hardest, so we're going to skip it. We're going to look at the two other ones first. So we're going to look at the question at the top right. So I know that angle 1 is equal to this angle plus this angle. Well, the top angle is marked as a 90-degree angle, plus the other angle is 20. So all I've got to do to find angle 1 is take and add 90 plus 20 to know that angle 1 equals 110 degrees. Again, doing something very similar for that bottom question, angle 1 is going to equal the sum of these two angles over here. So 60 plus 60. So angle 1 has to equal 120 degrees. For the top question that we skipped, the reason that we skipped it is because we were given the outside angle. When you're given the outside angle, we know that the outside angle equals these two angles here added together. So angle 1 plus 112 has to equal 131. In this case, you would subtract 112 from both sides to get that angle 1 equals 19 degrees. So that one just had a little bit different process. So here's a problem that they've added in Algebra 2. So we're going to find the measure of these angles. The first thing we've got to do is find x. So to find x, the first thing we want to do is say that our two interior angles here are going to equal the exterior one here. So we know that 13x minus 11 plus 4x plus 1 has to equal that exterior angle of 18x minus 15. We're going to combine like terms, so 17x minus 10 equals 18x minus 15. I would subtract 17x from both sides. So negative 10 equals x minus 15. Add 15 to both sides to get x equals 5. Once you have this answer, you're just going to take the x's and plug them back in. So when I find angle CAB, if I follow from A to B, it's talking about this angle right here. So it's talking specifically about angle A. So I'm going to take 13 times 5 minus 11 to get that angle of 54 degrees. If I find angle, let's see, ABC, that's this angle here, I'm going to take 4 times 5 plus 1. 4 times 5 is 20 plus 1, 21. Tricky question here. Well, the next one asks you to find ACB. That is this angle right in here. So there's a couple different ways you can find angle ACB. We know that angle A plus angle B plus angle C has to equal 180 degrees. So if I take 180, has to equal angle A, B, and C. Oops. We just found out that angle A was 54. Angle B was 21. And now we can solve this to figure out that angle C is 105 degrees. And then last thing we need to do is 18 times 5 minus 15. To learn that that angle or angle DCB is 75 degrees. The next one is very, very, very similar, so we're just going to run through it real quick. Your outside angle, 9x minus 8, has to equal 7x minus 32 plus 5x minus 27. Combine your like terms. So 12x minus 59. I would subtract 9x from both sides. I would also add 59. So negative 8 plus 59 is 51. 12x minus 9x is 3x. Beside it, divide it. So divide both sides by 3 to end up with x equals 17. And then we're asked to find those four angles again. So JKL. JKL is this angle up here. Again, if you follow along, J to K to L, it's talking about this angle here. So I'm going to take 7 times 17 minus 32 to get 87 degrees. For the next one, you're asked to find KJL. That's this angle over here in the bottom left. So 5 times 17 minus 27 gives you a value of 58 degrees. To find angle KLJ, that's the angle that has no information labeled about it. I'm going to take 180 and I'm going to subtract the two angles we already know, 87 and 58. And that tells me that that angle has 35 degrees left for it. And then to find the last one, KLM, that's this angle right here. So the 9x minus 8, if I take 9 times 17 minus 8, I get 145 degrees. There are specific things that happen when we have an isosceles triangle. So parts of your isosceles triangle, you have two congruent sides. Those are called your legs. The angle where your sides intersect is called the vertex angle. In this case, your vertex angle would be angle B, or angle 1, if that's how you wanted to call it. The sides opposite of your vertex angle, so opposite of B, is this side down here. That's called your base. And then the angles that are along the base are called your base angles. So both A and C would be base angles. So your isosceles triangle theorem says if two sides of a triangle are congruent, then the opposite sides are also congruent. So for example, if line segment AB is congruent to line segment BC, then angle 2 has to be congruent to angle 3. And the opposite of that is true. If I give you that angle 2 is congruent to angle 3, then those two sides have to also be congruent like that. So for this slide, we're being asked to find the measure of each angle. So for question number 1, we're being asked to find the measure of angle J and angle K. One of them is pretty straightforward. So using our isosceles triangle theorem, we have two congruent sides. That means the angles opposite of those sides have to be congruent. So angle J and angle L have to be congruent to each other. So this angle has to be 68 degrees. We also know that the sum of our interior angles of a triangle has to equal 180 degrees. And we know two of the three. We're going to call that third angle, well, we should just call it K. So to figure out what angle K is, I'm going to take 180 minus 68, and I get a value of 44. Number 2 is kind of a tricky question. I know there's a question similar to this on a test. So I'm giving you an isosceles triangle because we have these two sides congruent. Since those two sides are congruent, these two angles have to be congruent. So here I know that 180 equals 106 plus I have two of the same angles. I'm just going to say the angles x. So then I would solve this. I'd subtract 106 from both sides. So 74 equals 2x, divided by 2, and x equals 37. That means that both of these angles, since they have to be congruent, they're both going to be 37 degrees. Question 3 changes things up a little bit. So they're giving you two congruent angles, which means the opposite sides have to be congruent. So line segment XY has to be congruent to line segment ZY, which means they both have to be 12 centimeters. And then last but not least, we're asked to find the measure of angle Y. That's this angle in here. So we're going to take 180, subtract the two angles that we know to get a value of 26 for angle Y. Again, you can double check if I plug 26 in here and then I add all three of those angles together, you should get 180 degrees. The algebra side of this, you're either going to really be given congruent sides or congruent angles and being asked to set them equal to each other. So for this first question on the left, we have two congruent sides, which really tells us that we have two congruent angles down here at the base. If these angles are congruent, we can just set them equal to each other. So 4x plus 7 equals 9x minus 33. Go ahead and solve that for x. So I would subtract 4x from both sides. Oops. I would add 33 to both sides. Divide both sides by 5 to get an x value of 8. Kind of the opposite of that happens on the question on the right. You're given angles that are congruent. So since this angle is congruent to this angle, this side has to be congruent to this side because, again, they're opposites. So I'm going to take 15x plus 7 equals 23x minus 17. And I'm going to subtract 15 from both sides, 15x from both sides. Then I'm going to add 17 to both sides, so 24 equals 8x. Beside it, divide it, and x equals 3. On the next page, you will find your assignment. You need to do all of the odds.